This is an A-level pure question on differentiation and it's a trigonometric proof. Given that theta is measured in radians, prove from first principles that d to theta of cos theta is equal to negative sine theta. You may assume the formula for cos a plus or minus b, and that as h tends to 0, sine h over h tends to 1, and cos h minus 1 all over h tends to 0. Okay, so the first thing that I've done is put up here a reminder of the formula that we use for first principles. Okay, so let's start this off. So the derivative d to theta of cos theta is equal to the limit as h tends to 0 of, now this will be cos theta plus h. So basically you need to think of the theta being like x in the formula, minus cos theta all over h. Now I'm only going to write this down at the start here and then at the end, the limit as h tends to 0. I'm not going to write it in every line of working. Now this is the point at which I use the expansion for cos a plus b, which is what I've got here. So what I'll have, the expansion is going to be cos theta cos h, and then if there's a plus here, there's a minus in the expansion, so minus sine theta sine h minus cos theta all over h. Now what I'm going to do is to rewrite this, group together the sine terms and the cos terms, and I want to try and get this type of pattern, sine h over h cos h minus 1 over h. So that's what I'm trying to get to, because then I can use these assumptions here that were given in the question. Right, so let's put the sine terms together, and we'll split them all up as well because they're all over the same denominator. So let's write minus sine theta sine h over h. Okay, so that's all my sine terms put together, and then plus, and then I'm going to have cos theta cos h minus cos theta all over h. So I've split them up, put the terms together. I want to get this form here, so I can write the first term as sine h over h times by negative sine theta, just rewriting it. So there I've got the sine h over, that's what I wanted. And then for the second one, to get this thing here, I need to factor out cos theta and put that at the end. So I'm going to write cos h minus 1 all over h and times by cos theta. Now I'm going to use my notation here, the limit as h tends to 0, because I was given some stuff in the question. So I'll just highlight the bits I was given. So sine h over h, I know that's going to tend to 1, and cos h minus 1 over h, that's going to tend to 0. So as h tends to 0, this tends to 1, so that just leaves me with negative sine theta in the first term. And then for the second term, well, if this bit tends to 0, this bit's just gone, so I'm just left with negative sine theta. So I'm pretty much done. I can say that the derivative of cos theta is equal to negative sine theta, and we've done that by first principles.